Okay, what's up everybody? This is day 7. Now this is going before me actually solving the problem. The reason is I actually struggled on this one with the string parsing part. And I've said this in previous days, I just need to learn Regex better. And shout out to Dave DeLong again for sharing some code. I spent some time, I made an extension. I'm going to show it to you now. So when you're watching the rest of the video, if you're getting annoyed by how frustrated I'm getting with string parsing, because it could all be done with Regex, you can skip it because I'm going to show you how to solve the problem right now. So first of all of the recursive functionality, which is tying the bags together, going up and down the tree, that's all staying exactly the same. So no change there. The difference that I've made is this was my nasty string parsing stuff, and this was my nasty string parsing stuff, and all of that gone. And it is reduced down to this, two regex patterns that end up pulling out all of the results. So basically how each of these works, again, shout out to Regex 101, I love this website. So here's an example line of input. So I'm going to do this, and you can see it pulls out the light red part. Awesome, exactly what I wanted. And then this one pulls out the number, pulls out the color. Awesome, and it repeats. So loving this. This is way better than what I had. So let's show you this string.matches. This is something that I threw together. I probably would not ship something like this in real code, but it's helpful for making quick changes to Regex and doing like this kind of small pattern matching that you would get with these kind of programming problems. So let's look at it here. So basically all I'm doing is this is a function that creates the regular expression for you. It does this yucky making a range thing for the string, and then it takes the regex, and this should not be description, this should be self. I'm guessing that only worked because string has description defined on it. It happens to be the same as the string itself. Okay, anyway, fix that. So you enumerate the matches, and what I'm doing here is I'm basically, rather than exposing this regex directly to you, I know that for basically all the problems, I just want an array of strings where each inner array is just the matches for each particular pattern. So in this case, this would be one match, this would be the next match, right? So the one other interesting thing that I'm doing here is for each match of the regex, I'm throwing away the first match, because the first match is always the full match. So if I click on the full match, you can see it's the full, not sentence, but the entire thing that matches the pattern. When what I actually want out of this is the capture groups. And again, this is part of the reason why I probably would never ship this, right? Because I don't know that people necessarily expect that the full match would be tossed out. But this is something that, like, I know that I'm probably never going to use in these programming problems. So I'm tossing it. Okay, and then after we build up an array of arrays out of these, then I return it. So this little extension right here, these are some other extensions that I make later in the video because I got annoyed with string to in a string conversions. Makes it so that all it is to get the color of the outer bag is this. Yeah, see, look, it's ugly. Wouldn't use this in production code, right? But for this kind of programming problem, super handy. And I'm sure that if I had a little bit more thought and a little bit better use case, like, I can probably actually make a production ready version of this. In fact, again, like I said, shout out to Dave DeLong sharing code. I'm going to link his GitHub repo down below. So if you want to see his awesome wrapper around Regex that does really well, like, go ahead and use it. It's awesome. Thanks to him for sharing that and for being willing to teach me some regex tricks. So this is awesome. Let's get to the rest of the video. All right, good morning, day 7. I hope you guys are excited. It's just so fun. I can't believe we made it to day 7. Advent of Code is just one of those things. It's like drawing for Inktober if you're familiar with that. It's a challenge, but it's like I feel like it's super rewarding. So if you're still going, congrats to you. This is exciting stuff. Let's jump into day 7, shall we? All right, you landed at a regional airport in time for your next flight. In fact, it looks like you'll even have time to grab some food. All flights are currently delayed due to issues in luggage processing. So that's what we're doing today. Due to recent aviation regulations, many rules, which is your puzzle input, are being enforced about bags and their contents. Bags must be color-coded and must contain specific quantities of other color-coded bags. Apparently, nobody responsible for these regulations considered how long they would take to enforce. For example, considering the following rule, light red bags contain 1 bright white bag, 2 muted yellow bags. Oh no. These rules specify the required contents for 9 bag types. In this example, every faded blue bag is empty. Every vibrant plum bag contains 11 bags, 5 faded blue, and 6 dotted black, and so on. Oh gosh. Yeah, right here, vibrant plum. Okay. You have a shiny gold bag. If you wanted to carry it in at least one other bag, how many different bag colors would be valid for the outermost bag? In other words, how many colors can eventually contain at least one shiny gold bag? Is it asking me to nest these bags inside each other? I think it might be. Oh, that'd be terrible if it is. The above rules. The following options would be available to you. A bright white bag, which can hold your shiny gold bag directly. A muted yellow bag, which can hold your shiny gold bag directly, plus some other bags. A dark orange bag, which can hold bright white. Okay. Yeah, so it wants them to nest inside each other. So not only is it asking which bags can contain it, which would be decently easy, I think, it is asking us to nest inside and try to find what other bags would be allowed to carry our bag. So in this example, the number of bag colors that can eventually contain at least one shiny gold bag is 4. How many bag colors can eventually contain at least one shiny gold bag? The list of rules is quite long. Make sure you get all of it. Well, here goes. So normally, what I would do in this situation is start with this. And I think I'm going to do that because they tell us the answer, right? But I'm going to quickly look at our puzzle input and just make sure that it is formatted exactly like this so I can pay attention to any formatting rules before we parse this stuff. So a muted tomato bags contain 1 bright brown bag, 1 dotted gold bag, 2 faded. Okay, so it looks like the sort of grammar that we're supposed to be parsing is bags are split by a new line, the contain word, and then it's a comma separated list, and then it ends with a period. Okay, that's pretty easy. I think we can do that. They weren't joking. The list is long. Okay, we'll come back to this in a second. We're going to start with the short input because that looks easier to make sense of. Plus, they sort of give you the answer. So, like our other answers, I'm going to create a struct to hold all of this, and this is called bag rules. And then bag rules is going to be is going to have an outer bag, which is going to be a string, so it'll be like light red, and then it will be, and then the inner bags will be an array of strings, and then the initializer on this will take in a string, and it'll parse this out. So to parse this out, first thing we want to do is we want to get the outer. So let's see. So I'm going to do components equals string.split on, well, first we're going to split on the word. Oh, I can't split on the word. We're going to use the as in a string trick again because it gives us the thing that we want. And we want components separated by contain. So that will split it right here, and it will give us this bag and this part and this part. So then what we're going to say is self.outerBag equals components.first, and then for the next part, we are going to split the second set of components on comma space. We're gonna remove this first. So let's do that. So we're gonna do first. Let's do remove last equals prefix with the max length is string.count -1. So that should drop the period. Excuse me. That should drop the period, and then we're going to use remove last since it has no period. And then now that we have the components, we have the first component. Now the second component, since it has the period dropped, should just be this part right here. So what we're going to do is we're going to split it based on comma space. So let's do that now. So we're going to say components. We're now doing a new thing. Components equals components first dot split, and this is going to be, I don't know, it's offering me components. Is that because this is an array of, that's weird. Oh, components separated by character set, that's why, and I don't want to compose a character set. Okay, that's why. Okay, so we're going to do this again. I should just, you know what I'm going to do is I'm going to throw, this is the text input from day one, extension on string var ns is of type ns string, get return self as ns string. Is that happy about that? I don't think it's complaining about that. So what we're going to do, we just do this so often, we're going to just start using this everywhere. Okay, we're going to do this too. Fine, I'll make an extension for everything. And then same thing. Happy now? Okay, that one's happy. Components.ns.components separated by, and this time we're separating by the comma space. So this will get us all of that. And then, okay, so the last thing we want a bag rule. Okay, so file private struct. So a bagged rule, I guess those are bag rules, and this is a bag rule. So we're gonna have the count. I'm assuming this is gonna play into part 1 because it certainly doesn't play into part 2. And then the color is a string. Okay. And so this is going to be an array of bag rule, and then what we're going to do, we're going to take these components and we're going to We're going to turn these into bag rules. So now we should have, yep, a list of strings, which is awesome. And then that list of strings is going to do this, self.inner bags. We're going to turn these components and we're going to map them into bag rules. So this is basically going to be, I'm calling it a tuple, even though it's not a tuple. It's separated by, oh, it's separated by space. Yuck. But all of these are spaces. Okay. Regex to save the day. I don't know what I was trying to say there. Okay, so I think it's /d matches a digit 0 through 9 and then a space. Matches literally. Okay, and so then my input, which is this. Okay, so this is capture group 1, and then this is A through Z or white space. I think, or maybe it's supposed to be like this. Okay, second capturing group. Okay, match a single character present in the list below, matches between 1 and unlimited times. Okay, I think this is our regex that we want. Then we'll split it and we'll get the 2 capture groups. Okay, let's see, what is it? Split. What was what's it called? Where we did our regex on our previous episode. Whichever episode, 4. I don't remember what the function's called already. Range. Oh, but we don't want the range, because this just tells us the first appearance of that, and that's not what we want. We want actually split. We want the capture groups. We want those actually returned as the pieces. So we're going to do, see, that's range of, which just tells us if it exists, which is not what we want. Replacing occurrences, that's also not what we want. Okay. Since this is going to get hairy, I'm turning this into its own thing. This just to make it easier to read. Bag rule from string $0. Okay. Let regex equals ns regular expression pattern. Oh, we're going to use our what do they call it, raw string literal or something like that. Could use that here. We want this. We're going to force this. Oop. And what options? We can do empty set, it says. Okay, cool. Okay, and then we're going to say parts equals string. How do you actually use this thing? We've got the regex. Enumerate matches. Okay. Enumerate matches in string. And then what are our matching options here? And of course we have to get the range. Yuck. I just like, this is like exactly everything that I hate about working with strings in Swift is yeah, I've got to do this range thing. I don't want any options. NS range. Why did they call it NS range? They were using range earlier. Okay, and then the rest, I'm guessing, can be left off. Is it happy with that? No. Well, oh, because you have to do. So I don't understand why we need a text checking result. Is there another one? Is there another one that I could get here? First match. No, it always makes you do this. That is weird. I'm sure there's a reason. I just don't understand it. Okay, so let's see. Actually, you know, I'm already kind of sick of this. So, what happens if I do this? Yeah. Okay, what I'm going to do off camera is I'm going to actually I'm going to read how to do this right, and then I'm going to do write an extension to make this easier, because clearly this is going to keep coming up. And then what we're going to do is we're going to say self.count equals string dot range of and then we're just going to do the /d space. Actually, we just want the /d. We don't even need this space. This space was just to help consume that thing. Regex. Really? I swear this is what we did last time. How did I do it wrong? The regular expression. Hashtag. And it is /d. No. Okay. Cannot assign range. Yeah, okay, that's good. String, let's just keep it simple. Equals that self.count. Actually, this is going to be a var. We're going to reuse this. Self.count equals string dot substring in range, and then we don't need the rest, right? I can just close that up. Enumerate substrings. No, not enumerate. Substring in with range. This has been deprecated to what? Give me the deprecated option. How much of my time is wasted on dealing with string operations? Okay, we'll see if that actually works for us. And then the next time around, range is going to equal, instead of /d, it's going to be A through Z. A through Z. I think that's what we want, right? So I can just actually, I can take this and, oh yeah, it needs the plus, huh? A through Z plus. No. Yeah. Ooh, I don't want the white space at the beginning though. Yuck. Okay, well, regex skip leading white space, I guess, maybe. Ignore leading and trailing spaces. /s star. Okay, I've never tried that before. Matches any white space character. 0 unlimited times. Is that really what I want? Okay, you know what? Screw it. I'll read that later also. And in the meantime, what we're going to do is going to do range of that. And then we're going to do self.color equals string.substring. Please use, well, if you're not going to autocomplete for me, I'm not going to do that right now. Range. And this should work, but what we want to do is we want to do suffix. What do you mean int? This is not an int. Okay, so now what we'll do is you can do suffix with a max length of, this is so annoying. There's got to be a better way. Equals this, and then it's going to be equals color.suffix color.count -1. Holy cow, that's ugly. Okay. See, and this is again like, why on earth do I want substring? I don't. It's useless. Okay. Let's see if that even works. Let's see if we can get anything working with that. I did not. Did I do this already? I did not. Man, we were starting off so good and so positive, and then string parsing just got me down. So we called it input, yeah. Dot split using the new line character, and then map it to bag rules. $0. Okay. Perfect. And again, like, why I don't want substring. So that's what I'm doing tonight, is I'm going through every single one of these, and I'm making wrappers for all of these operations because it's driving me crazy. All right. Let's run that then. Self.inner bags. Let's see how that works. Outer bag, light red bags. Okay. I'm actually probably going to be searching for light red directly. I'm already realizing that. And then inner bags are, did those come out okay? One bright yellow bag. So what we actually want here, that's kind of lame. Okay, so the count, I'm looking at the wrong thing. The outer bags, we want to split by contains, but not, we want space bag contains space. Bags contain, because then that will just get us the color of the bag, which I think is what we want. So light red can contain one bright white and two muted yellow. One light red contains one bright white, two muted yellow. Okay, that's usable now. Let's let it rip, and hopefully it doesn't crash on us. Spoke too soon. Fatal error found nil. No other bags? What? Okay, contains no other bags. Okay, if string equals literally no other bags, course they got us with that one. Self.count equals 0, self.color equals empty, I guess. And then return. Okay. That's kind of lame, but okay. Now, so what we're doing here is we're going to be searching. We're going to be searching for shiny gold bags, and then we're going to do it recursively with this list of bags. Okay. So this is going to be a recursive function, count containing, and then we're going to say bag color, which is going to be a string. In our case, it's going to be shiny gold, and then this is going to be rules. And this is going to be an array of bag rules. Why didn't I like that? And then it returns an int. And I'm actually going to make this, just to make my life easy, I'm going to make this in out. And then that means this will have to change to a var, which means I'll actually probably need to copy this for part 2 or rebuild it is what's going to end up happening. Okay, so what we're going to do is we're going to check the list of bag rules, remove any bag rules that that will let us contain shiny silver bags, and then do it again. So rules dot filter, this returns the bag rules. Okay. Returns an array containing in order the elements of the sequence that satisfy. Okay, that's what I want, more or less. Okay, so what we're going to do here is we're going to say that can contain. Cannot contain, I think, is actually what I want to do here. So what we're going to do is we're going to, no, we want, well, okay, what are we looking for? We are looking for this first pass, we're looking for anything that can contain it, but we're going to remove those. We're going to remove the ones that can contain it because they've already been found. So we're not, when we recurse, we're not going to use those. Okay. So what we're going to do is we're going to say rules dot let's see, $0 dot inner bags dot let's see func can hold, and it's going to be a color string, and it's going to return a bool. So what we're going to do is we're going to say $0 dot can hold bag color. Okay. Cannot hold bag color. For rule in self dot inner bags, if rule dot color equals color, return true. Okay, so look for the first instance of a rule that can contain an inner bag, and then if we don't find one, return false. Okay, so this will get us the list of bags that cannot hold it. So the rules that can hold it is going to be the difference between these two. We're going to say var can hold equals rules.count minus cannot contain.count. And then, oh, so this doesn't need to be an out. That's nice. Yeah, because then because I'm going to filter in, I'm not filtering in place. If Swiss filter in place would do that, I'd make that in out, but it doesn't have to. And then we're going to say for bag in cannot contain. Well, let's see. So now what we want to do, now that we have all the bags that couldn't hold it directly, we now want to see if any of those that could hold it can now hold it, which is not helpful. Okay, I'm approaching this wrong. I actually need to split this array into two arrays, one that can and one that can't, because then what we're doing is for every bag that can hold it, we're looking for its color in the remaining bags. Do we even need to filter it? I'm going to try not filtering. We're going to change this to can hold. Let's see. No, you do, because you'll end up double counting if I don't actually filter. Is there a split where separator? That's not what I want. Array into groups. I don't know into chunks maybe. What's the chunks now? Am I just gonna have to go over it twice? Contains. This is like so hacky. This is so hacky. I am not happy with today's solution at all. This is one of those that I definitely want to. I want to go back and do something about. Contains does not, which is annoying. Okay. For rule in rules, if rule dot can hold bag color contains equals, let's see, can hold can hold dot append rule, else cannot dot append rule. Okay, so that should split it into two sets of rules, and then for every can hold, we need to go through all of the cannots. Okay, so count equals can hold dot count, and then for rule in can hold, we need to say count plus equals count containing rule dot outer bag and the cannot. Okay, so we need to go through every bag that can directly hold our shiny gold bag. And we need to see, so if it's a white bag that can hold a shiny gold bag, we need to go through all the other bags that couldn't hold a shiny gold bag and see how many of them could by running it back through the same function, and so on and so on and so on, and then pass the result back out. I think that's a good recursive function there. We'll see. So let's say print count containing shiny gold, and then the rules. And this can be a let now. Let's see how close we get to the actual answer. None. Okay, fair enough. So this is where we actually step through and find the bugs. So the first one, light red bag, should be able to right off the bat. So let's do that first. We have what is rule? Rule is light red, and the two inner bags are bright white bag, muted yellow bag. Bright white bag. Ah, dang it. Okay. Do we split based on bag? No, because we have that at the end. Let's remove it. I think that sounds reasonable to me. Dot remove dot replace placings occurrences of bag with nothing. Dang it, with bags with nothing and bag. I'm going to learn so much today from reading other people's answers, I can already tell. Okay, bright white, muted yellow. Let's see. Bright white, muted yellow. Okay, let's run that. 6. Now we got 6 this time. Is 6 the right answer? Okay. How many bags? Okay, so in this example, the number of bag colors that can eventually contain at least one shiny gold bag is 4. So, I'm guessing, so some of the bags are getting counted multiple times because they can contain multiple branches. So I think I actually do need to change this to be in out, so that we're all working from the same set of rules. And then what we need to do is we are trying to and then we're going to say we don't need the cannot, because we don't want to pass to multiple branches. Dot remove what am I trying to? I'm like going brain dead. Okay, enumerated, and then this is the element and the index and the element, index and the rule. Is that right? So the rule and the index. Yep. Dot remove at index. Okay. That should prevent us from using the same fix. Yep, it wants an explicit ampersand. Okay, that should prevent bags from getting double counted. That got us down to 5, which is still not the correct answer. The correct answer for this is, so in this example, the number of bag colors that can eventually contain at least one shiny gold bag is 4. And rule.color does not equal no other bags. Is that what we, no other bags? 5 still. Okay, so that's not the issue, but I imagine that actually could have come up as an issue. Okay, now we start stepping through this again. And we see the rules in action. Okay, let's do it. rule.canHold. So the first rule, let's shrink this window so that we can see these rules in action. Okay, so now we have a light red bag contains one bright white bag. Okay, so this one should be a no. Okay. This one should be a no. Bright white contains one shiny gold bag. Okay, good. So bright white. So that looks like it's working. It's skipping stuff. Okay, let's see what we end up with on the can hold. In this example, every faded blue bag is empty, every vibrant plum bag. Okay, so how many can directly contain shiny gold? In this case, 1, 2. 2 bags. Can hold. 2. Okay, that's pretty good. And then bright white. 2 bags can hold bright white. Muted yellow. The same 2 bags can hold muted yellow. But that shouldn't be a problem. Okay, so let's print out rules here. What? I'm clearly missing something here, right? Because shiny gold, bright white, and muted yellow should not be at 2 and 3. Yeah, muted yellow is still here. It's going to remove an index because it's going to remove an index and the index is going to change. So it's actually filtering the wrong things out. Let's see. How do we do this? There's a way. Oh my gosh. There's a way to do this. Feeling so rusty right now. I don't know if this will actually work. I don't think that it won't. Actually, I know this won't work. Okay. Done. Array of what is index? And okay. That's how brain dead I'm feeling. I'm thinking in string indexes. Rules.remove. Oh my gosh, wow, I'm so brain dead right now. For index and indexes dot reversed rules dot remove at index indexes dot append index. That is clunky too, but my brain's not working. I am so looking forward to coming back with a better answer for some of these things. Okay. So what do we have here? Rules. Why does rules still have, what did rules start with? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it did have 9. Okay, so I'm not crazy there. Dark orange, and then it jumps straight down to shiny gold. Okay, so we're gonna run this once, and then rules now has 5 values, presumably because light red and dark orange got removed. Yep. So these 4 have all been removed, and then we move on to the next part. So then the answer should be 4. Okay, let's try it with the real puzzle input now and see how badly it blows up. 289. Submit that. That was it. That was really rough, you guys. Man, it's almost like embarrassing to post this because that was really rough. But there's going to be a learning opportunity here, so we'll get at that. Okay, it's getting expensive to fly these days now because of ticket prices, because of the ridiculous number of bags you need to buy. Consider again your shiny gold bag and the rules from above example. Okay, so a single shiny gold bag must contain 1 dark olive bag and the 7 bags within it, plus 2 vibrant plum bags and the 11 bags within each of those, which turns out to be 32 bags. Of course, the actual rules have a smaller chance of going several levels deeper than this example. Be sure to count all of the bags, even if the nesting becomes topologically impractical. I don't know what that means, but I'm going to assume it's just flavor text. It's like I'm reading a magic card now. It's got that flavor text at the bottom. So here's a new example. Must contain 126 other bags. Okay, so as expected, the count does play into this. Whoops. The count does play into this, so glad we got the count. We're gonna so this is part 1, and this is part 2 print, and then so what we want is literally this function but going the opposite direction, where we're going in instead of out. So file private func contains count required nested bags. So bag color, which is going to be our starting bag, and then the rules, which are going to be in, out, bag rules again. And then that will be that. Okay. So now instead of can hold, what we're actually trying to figure out is needs to hold. What's wrong with rules? Rules, semicolon, I can type. Okay. So then what we want to do is we want to say rule dot outer bag equals bag color. Then needs to hold rule, and then we'll see. So this part right here is the part that I'm not sure about, because I think it could actually go on forever, and that wouldn't be an issue. So we'll see if we actually need this. So we put those into needs to hold. So this one actually might not need to be in out, honestly. This is needs to hold dot count, and then for rule in needs to hold, we're going to say required nesting bag blah blah blah. This might not need to be in out, but we'll find out. And then rule dot crap, so this isn't exactly right. So we need to go through each inner bag. So for inner in rule.inner bags. So it's count plus inner dot count times inner dot color. Right? I think I'm thinking about this right, because you have to go through each one and multiply it. So so this would be count plus equals 1 for the bag itself, and then no, wait, you have the bag itself already. Okay, I think that's right or close to right. Required nesting of shiny gold and rules. Let's 127. Was that right? 126. Because it's counting the bag itself. So count starts out at I could just subtract 1 myself. That's suspiciously correct first try. I don't know why part 1's failing now. Well, that doesn't feel good. But, oh, duh, because I changed the rules. I do know why it's failing. Okay, let's try with our real input. 30,000, whatever that is. It's not the right answer, it's too high. Okay. Oh crap, it's gonna be -1, huh? And I forgot to do the -1. It's gonna be 55. And I have to wait. I have to wait 47 seconds. Okay. So, man, that was gross. I mean, the code, this is the crazy thing. The code's not actually that long, but this right here, this is disgusting. I need to come up with a better way. Because this is basically parsing out a grammar, and this is not a good way to do it. I was recently reading a GitHub repo for a guy that wrote his own language, and I kind of want to go see what he did for his parser and his lexer, because I'm going to assume that I want to do basically the same thing here. Can we submit now? There we go, the 1 gold star. Okay. I'm not going to go on right now because I think it's pretty clear that that this was not a smooth ride. I'm going to go read some stuff, come back, and then once we have a better idea of some of the takeaways, I'm going to come back and record again. So, all right. We'll catch you in a minute.